So 9.2 is the start of doing z-tests and t-tests and rejecting the null and all this stuff that is going to continue on for the rest of the semester. There are just going to be slight variations on the theme. And within these tests, there's two different ways to do the calculation, which will give you the same conclusion, but the different homework sections are always asking people to do it one way or the other. So first is the critical value method, and but either of them are going to start with the same thing of stating the appropriate null and alternate hypothesis. So this applies to whether you're doing the critical value method or the p-value method, that you need to find the null and alternate hypothesis. So just like I talked about in section 9.1, the null hypothesis is always, this is going to be like a drop down menu, or it might look a little bit different now, but anyway, they're going to pick equals always for the null hypothesis, and for the alternate, it's going to be either greater than, less than, or not equal to, and that depends on keywords in the actual problem. So a study showed that 2 years ago, the mean time spent per visit to Facebook was 20.2 minutes. Assume the standard deviation is 10 minutes, and notice that that's a sigma, and that is one thing that will tell us that this is going to be a z-test, because we have a population standard deviation for reference here. We also know that all of section 9.2 uses the z-test, so if they know they're doing a problem from 9.2, it's always the z-test. Suppose that a simple random sample of 103 visits, that's going to be the n we'll use later, was selected this year and has a sample mean of 19.2 minutes. We'll use the sample mean later. A social scientist is interested to know whether the mean time on Facebook visits has decreased. And this is what we're looking for right now. Decreased means it's going to be a left-tailed test, and that means we're going to use less than for the alternate hypothesis. And it has decreased it. So they're wondering, has it decreased, but has it decreased from what? From what it was 2 years ago, at which point it was 20.2 minutes. So our reference sample, in this case, the study 2 years ago, is what's going to go into both of these boxes for the number. So in the end, the null hypothesis will be that the mean is equal to 20.2 minutes, meaning it hasn't changed, and the alternate hypothesis will be mu less than 20.2 minutes, meaning it has decreased. And because we use the less than symbol for the alternate hypothesis, that means it is a left-tailed test. So that's going to come up in part one of every one of these problems in 9.2 and some variation on that for the rest of the semester. Next is find the critical value. This is only because we're doing the critical value method. And so in this case, to find the critical value, we're going to use that PDF file of tables. And on the very last page of that PDF file is table 9.1. And it is just a very nice, compact little table to find just what you're looking for without a lot of clutter. And so in this case, we have the alpha equals 0.1 level of significance. So we're looking on here, significance level 0.1. So we're going here, and then we already know it's left-tailed. So this is the value for the critical value, negative 1.282. Then it asks us to compute the value of the test statistic. So this we're actually going to do whether it is the critical value or the p-value method. We're just going to use a different value from the results. So we will do stat tests z-test, the very first one. Our input is going to be stats because we don't have a table of data. What we put in for mu0 is always, always, always going to be the same number that we used up here, which in this case is 20.2. 20.2. Sigma is the standard deviation that we're given, which is 10. And sample mean is for the new study, simple random sample of 103 visits, had a sample mean of 19.2 minutes. N is our sample size, which is 1 of 3 given in the problem. And then here we just have to match it to what we did in part 1 and for the alternate hypothesis, and it was less than in this case. So we're going to switch this to less than. That color blue line, that won't show up on the regular TI-84 calculator. And if it did, if someone had the color calculator, it doesn't matter because we're not drawing it anyway. And calculate. And so if it's asking for the critical, or sorry, not the critical value, the test statistic, z, is this, negative 1.012, 2 decimal places, so negative 1.01. Then we have to determine whether to reject. And in the case of the critical value method, we reject it if our test statistic is what's called more extreme than the critical value. So our critical value was negative 1.282. To determine the more extreme or not, we're going to take the absolute value of them both, and if our calculated value is more than the critical value, then we reject. And so in this case, our calculated value is 1.01. It is not more than the critical value of 1.282, and so we do not reject. So that's what we would do here. It'd be a pull down menu, do not reject. These are all screenshots. I don't have the actual connect, so that's why I can't really do the pull downs. And then it's always going to ask you to state a conclusion. So if we said we do not reject, then we would say here that there is not enough evidence. So you're matching it in that if you say not for part 4, you also say not for part 5. If you say is for part 4, then you say is for part 5. So that is the process here when it's the critical value, and then I'm going to find let's see, that's critical value method. Now, say p-value method. I like the p-value better. And fortunately, the homework has shifted toward having more p-values than critical values, usually just one critical value somewhere toward the beginning, and then you don't need to do it anymore. So, null and alternate hypothesis, it's the same process. We're looking at what we're comparing to. In this case, school superintendent wants to know if the second graders have weaker math skills. Weaker math skills means a lower score on the test, so it's going to be less than, so it'll be left-tailed, and weaker than the nationwide average. The nationwide average, this is the mean score. Nationwide average is 52, so that's what's going to go here. This one actually asks you for the test statistic, Normally with the p-value ones, it doesn't even ask you for that, but it doesn't matter because it's all given in the same place. So I'm not going to redo the test. I'm just going to show you where from this. So you'd enter the numbers into the z-test, just like for the example with the critical value method. If it happens to ask for the test statistic in one with the p-value, it's fine because it's just right there in the output. But then the new thing here is that it asks for the p-value. The p-value is right here also in the output. And then when you determine whether to reject, you're just comparing the p-value to the alpha. If the p-value in your calculation is lower than the alpha, then you reject. So the reason I like this one is you don't have to look anything up in a table. You're just, you're given the alpha. In this case, the alpha is 0.05 and our p-value is larger than that. It's not lower. So that would make it a do not reject. I realize this isn't the real data that goes with this, but just pretend. Okay, so if our p-value in this case were less than 0.05, then we would say reject. If it's more than 0.05, then we would say do not reject. And then just like with the critical value, we match it up. Either the word not shows up in both of these drop downs or in neither. So if you said reject here, then you'd say there is enough evidence. If you said do not reject here, then you would say there is not enough evidence. And those are the only two things that come up. They're all either going to be p-value method or critical value method. You can also end up with the data rather than stats. At this point, you probably know exactly what you're going to do with that, which is stats, test, z-test, and you're going to do data. And then you would have entered your data numbers from the table into L1. And if it's a z-test, then you have a standard deviation given to you because that's your reference standard deviation. That would be right here, sigma equals 4. And then here you put your reference that you're going to be comparing to. And let's see if we can find that real quick. Amount less than 15 micrograms per liter. And so that's what would go here, the 15 micrograms per liter. And that's also going to be the number in your null and alternate hypothesis. And if it meets the standards, it has to be less than. So here you're going to be less than, it's going to be left-tailed. And then this one's asking for the critical value and the test statistic. Nothing else changes here, and how you reject and the conclusion. So that's all pretty much all the same stuff. I'm just going to make sure. Oh, okay. And then if it gives you this interpreting the calculator display, it's the same calculator display as your calculator will give you, so you'll know what to do with all of that. So, yep, that's it for, what is this, 9.2.